Hi guys, today's lesson is going to be on scatter plots again. Now we're going to be looking at lines of best fit. A line of best fit, or a trend line, is a line that passes close to as many points in the scatter plot as possible. And remember, it has to be a straight line because we're drawing lines. So for this example, we have a scatter plot that's comparing height to weight. If we wanted to draw a trend line for this, we'd want to draw the line that goes as close to as many points as possible. So drawing this trend line, Alright, so let's take a look at this example. If we want to draw a trend line for the scatter plot that is comparing height to weight, we'd start by trying to draw a line that goes as close to as many dots as possible. So if we start a line down here, I'm going to draw it straight up, and right about there it looks like it's going as close to as many dots as possible. So our trend line, or our line of best fit, is a line that goes through all our data points and as close to as possible. And if we look at this, these data points will have a positive correlation because the slope of that line looks positive. If we draw the line, we can also write an equation for that line of best fit. So to determine the correlation of a graph, draw the line of best fit, or your trend line. Find 2 points on that line and write the equation using the 2 points on the line. We know how to write an equation from 2 points. We need to find the slope, and then we can put it into point-slope form. So that's what we're going to be looking at today. So here we have a scatter plot that's comparing scores to hours of study, and they have the data points on there. So the first thing we're going to need to do is draw a line of best fit. So there I drew in a line of best fit. Now we're going to look at that line of best fit. We need to find 2 points that fall on it. I'm going to look right here. We have a point that falls on it, and it falls at an intersection, so I know exactly what that point is. I'm going to follow it up, and here we have another point that falls on our line of best fit. And again, it falls at an intersection. So those are good ones to use because they fall on intersections, and they make it easier for us to find the slope. So writing the coordinates for our points, looking at our first point, this point down here, we're going to write our coordinates. Our x-coordinate is 1, our y-coordinate is 50. Going up to our second point, our x-coordinate is 7, and our y-coordinate is 100. So now we have 2 points. If we're going to write the equation of a line, we're going to have to find our x1, y1, x2, y2, and then find our slope. Remembering, slope is equal to y2 minus y1 over x2 minus x1. So m is equal to 100 minus 50 over 7 minus 1. M is equal to 50 over 6, which is the same as 25 over 3. So our slope is 25 over 3. So now we have our slope and a point, and we can put the equation of this line into point-slope form. Remembering point-slope form is y minus y1 is equal to m times x minus x1. Once we have our slope and a point, we can just plug our information in. So y minus y1 over here was 50, so I'm going to continue to use that. So y minus 50 is equal to 25 over 3 times x minus x1, which again over here our x1 was 1. And we wrote the equation of the line. From here, you guys have worked on putting it in slope-intercept form, standard form, so you would be able to do that. But this is the equation of a line, so that would be good enough for this problem. The second example here. A little bit tougher because they don't have grid lines. All the problems you'll be working with will have grid lines. So the first thing we need to do is put our line of best fit in. Putting our line of best fit. That one looks pretty good. Most of the time in the problems that you're going to be doing, they'll already have the line of best fit in for you, so it'll be exactly how you want it. Going through this one without the grid lines, it makes it a little bit tougher, but we'll go up and we'll find points that we think look pretty good. Right here, it looks like it's at 2,000, 5. Then we'll follow it back a little bit more. Right about here, it looks like it's at 1,000, 15. So that gives us our x1, y1, or x2, y2. Working through the same thing that we just did, m is equal to y2 minus y1 over x2 minus x1. Plugging in the information, it's 15 minus 5 over 1,000 minus 2,000. So m is equal to 10 over negative 1,000, which simplifies to m is equal to negative 1 over 100. Then plugging it into our equation for a line, y minus y1 is equal to m times x minus x1. And then we just plug the information that we have in. Y minus y1, which y1 is 5, is equal to negative 1 over 100 times x minus x1, which is 2,000. I went into our graph a little bit, but that's the equation of our line. That's all we have for today. If you can complete N.7 with a SMART score of 80 or better, have a great day.